We would like to continue with our practice problems. So in number 7, we have torque is a measure of the force needed to cause an object to rotate. It is usually measured in foot-pounds. As part of a quality control program, Whirlpool inspectors measure the initial torque needed to loosen the balancing bolts on each leg of a clothes washer. So how much force does it take to loosen those legs on a clothes washer? A random sample of these measurements is taken and given in the following frequency distribution. So they have 6 classes beginning at 10. Their class width is 10 because they added 10 to get to 20, 10 to get to 30, and so forth. They have already given us the frequency. Given that frequency, notice that we can add up 4 plus 7 plus 5 plus 4 plus 3 plus 2, which gives us a total of 25 washers. Of those 25, we have already calculated the relative frequency. We took 4 and divided by 25. We got 0.16. 7 divided by 25 is 0.18. I'm sorry, 0.28. And we got all of the relative frequencies. We also already have calculated the cumulative frequency. 4. 4 plus 7 gives me 11. 11 plus 5 is 16. So forth all the way down to our end down here of 25. We need to fill in this missing column, which is the midpoint. Midpoint is 10 plus the next lower limit of 20 divided by 2. So 10 plus 20 is 30. Divided by 2 gives me 15. Just as we added 10 here, we can add 10 here. So we get 15, 25, 35, 45, 55, and 65. So we have filled in the missing pieces of the frequency distribution. Now we want to draw a frequency polygon for this data. Part of the reason why I had to have a midpoint is because my x-axis on a frequency polygon is the midpoint. So I'm going to draw my vertical axes and my horizontal axes. We are discussing torque, which is measured in foot-pounds. When we're doing a frequency polygon, again, my horizontal axis are the midpoints. So I'm going to start out with 15, 25, 35, 45, 55, and 65. Then we're going to have the frequency along our vertical axis. And we go anywhere from 0 up to 7 as our total. So 1, 2, 3, 4, 5. Whoa, can't skip that far. They need to be approximately evenly spaced. 4, 5, 6, 7. So I'm trying to get them approximately evenly spaced. So here's 1, there's 2, 3, 4, 5, 6, 7. A frequency polygon is a line graph. So I'm going to start out putting dots at 4, at 7, at 5, at 4, at 3, and at 2. And then I'm going to connect my dots. So I connect each of the dots in little line segments. This is my frequency polygon. I would also like to draw an ogive. It looks like ogive, remember, it's an ogive. I'm going to draw my vertical and my horizontal axes. I'm still discussing torque. in foot-pounds. Now for an ogive, we're actually going to use the upper class limits. So I'm going to use 19.99, 29.99, 39.99, 49.99, 59.99, and 69.99. Then on the side, on the vertical axes, I'm not going to use frequency, I'm going to use cumulative frequency. So instead of just the numbers of 4, 7, and so forth, I'm actually going to use that last column that was created, the 4, 11, 16, 20, 23, 25. So I'm going to come over here. So now I need to go up to 25. So 5, 10, 15, 20, 25. And then we can estimate in between. So my first cumulative frequency is about 4. My second is at about 11. Then I go up to 16. Then I'm going to go up to 20, 23, and 25. And again, the ogive is a line graph. And you'll notice the line graph on an ogive constantly increases, which is what it is supposed to be doing because we're talking about cumulative. We're always increasing. We can't decrease on a cumulative frequency. The last problem that we want to look at is a stem and leaf plot. We want to construct a stem and leaf plot. The intensity of light is measured in foot candles or in lux. In full daylight, the light intensity is approximately 10,700 lux, and at twilight, the light intensity is at about 11 lux. The recommended level of light in offices is 500 lux. A random sample of 25 offices was obtained, and the lux measurement at a typical work area was recorded for each. The data is given in the following table. We want to construct a stem and leaf plot. So recall that a stem and leaf plot, we have the stem, then we have the leaf. So we have 3 digits here. So the first 2 digits are going to go underneath the stem. So I'm going to start out with 46. The next one is a 49. Remember, I cannot skip any numbers here. So I'm going to have an 8 with the 46. I'm going to have a 7 with the 49. 468, 497. Then I do a 503. 526, so that means I've got to go to 52 here. 487, 482. This is not going to be my final stem and leaf plot. Right now I'm just trying to organize it in some type of manner. Okay? 463, 506, 531, so I've got to add a 53, 520, 464, 486, 481, 474, 488, 521, 516, 536, let's see, 503, 592, 581, 509, got a 560, so that means 53, 54, 55, 56. Again, I cannot skip these. So I've got 562, 520, and a 512. Again, this right here is just my organization. My final stem leaf plot, just like my stems have to be in order, my leaves have to be in order also. So I'm going to do 46, 47, all the way to 56. So 50, 51, 52, 53, 54, 55, and 56. Notice I have not skipped any of the stems. And then I'm going to look at the 46. I'm going to put these three numbers in order from the smallest to the largest. Just like on a stem and leaf, the leaf starts out small from the stem and gets larger. Same thing here. The 47 just has a 4. Now the 48 stem, I have to do a little bit more rearranging. I'm going to have a 1. Notice I'm going to also try to line up these, and if there's multiple ones, I have to put both of them down. A 2, a 6, a 7, and an 8. Then I have 492, 497, 503, 503, 506, 509, 512, 516, 520 twice, 521, 526, 531, 536, and 562. This is the final. This is just used to organize. Okay? You can put the values in order first if you would like. For me, it's just easier to go ahead and put them here where I have the stem and the leaf, and then I can rearrange them. So practice drawing the frequency polygons, the ogives, and the stem leaf plots. And if you have questions, please feel free to ask.